Hello, everyone. So today we will speak out about the final exam and what I'm expecting you from the second project. So please log into your courses, and then you will have a new two announcements. Uh, Please open the presentation announcement and also your final exam announcement. So for the presentation announcement, you have a module for this announcement. Here's the presentation announcement. It requires you to use ANOVA and regression analysis to investigate the effect of some factors on multiple outputs. You need to select one of the outputs. Will be two outputs involved, and basically also you will use either one-way ANOVA, two-way ANOVA, or two-way ANOVA with interaction. I will leave this option for you to select which type of ANOVA you want to present in your presentation. So, and it's very similar to the presentation one. So you need to have a title for the project. You need to have an introduction using visualization. And also you need to explain why you have used this method. So you can use one-way ANOVA for each factor separately, or you can use two-way ANOVAs, or if you believe there is an interaction, you can specify the two ways ANOVA. And then you will open a questions for the essay and write up a conclusion and add some citation. The only new thing here is you need to assess your colleague based on this website. So please open it. When you open it, it will give you a survey. You need to answer the survey basically after I post all your participation. So by the end of the survey, there will be an asking student name. So will be yours, and then your ID. So will be your ID, and then assist the project. So you need to say which student you have assessed. For example, this is Mike's project, and my name is Sam. So I will write down Sam, and my ID is 000, and I am assessing Mike. And please fill in a blank all these questions, all these multiple choices. So where the main idea is presented in ordinary and clean manner. So how do you think about that? And basically, based on your assessment, your student will have his scores in his project. It will be around 10 percentile of the total project. So let's go in depth about the presentation. So our problem for the presentation is the additive manufacturing mechanical properties and how they've been affected by process parameters. So like each fused decomposition modeling have process parameters. Usually it's the raster angle, so the way you print the part, the layer thickness, so how you are building up your part, the printing speed, the speed of the print, the gap between the fillers, and the filler percentage, the number of contours, the rafts, the support material, etc. All these are factors within considered to be process parameters. So how you control your 3D printing process, and based on this control, you will have different mechanical properties. For this particular example, I have selected only two process parameters, which are the printing speed and raster angle. You will have two files. One called is a training, whereas the main analysis will happen, and then we'll have the testing file. So when you open your file, you will download these files separately. Then first of all, try to build your presentation by answering these questions. So you will have 10 questions to answer. The first one will be illustration, a visualization for your test. So you need to show how these are working. Then the second thing, you need to build a story. And basically based on this story, you need to assign some questions, and these questions should be formulated through hypothesis. There will be two outcomes. So it's the yield strength or modulus, Young's modulus, and the other one is ultimate tensile strength. You need to pick one of these. So if I open the Excel sheet, okay, when I open the Excel sheet over here, so you will see this is the raster angle, the printing speed, the yield strength, and the ultimate tensile strength. So you need to select only one of these two columns of the output, but you need to select these two as a factor. So you need to build a hypothesis basically based on that. And then after you continue build that, you're gonna test it using your proper ANOVA. So you might be started with one-way ANOVA or two-way ANOVAs, it's up to you. And this is only set up for the training data set, not the testing. And then I'm asking you a question, does it need post-hoc technique? So maybe yes, maybe no. So you're gonna decide if it needs further analysis using post-hoc and why yes or why no. And then since we are going back to this Excel sheet, so these are not factorial factors, they are physical factors. So basically I need to predict the output based on these two variables. And you need to build a linear regression model. It's up to you if you wanted to include one factor or two factors or the interaction between these two factors. So you're gonna justify why you have done this approach. After you applying the multi-linear regression models, you will just only apply it again for the training dataset. So you're gonna use only this file. After that, predict the mechanical properties that you have selected using the testing dataset. So this is where the testing dataset comes. So after you build the model and optimize its parameters around the training dataset, you're gonna test it through the testing dataset. It's up to you if you want to create the confidence interval for it. After that, I want you to set up the mean square error for both data sets. So you need mean square error, mean absolute error, and the R square for both of them. Since I separated these two data sets, I am open to any kind of software. So you can use the Excel, Minitab, or R Studio. It's up to you. And so I didn't want you to link between these two outputs. So I want you to link between the Young's modulus and ultimate tensile strength. Usually we have some other methods. For example, we have orthogonal arrays if they are parallel, but these are not parallel. These are maybe having some correlation. I want you to investigate if there is a relationship between these two outcomes. Make a record presentation and then post it. Okay. Please don't hesitate to have any questions. Please back to me as soon as you can, and I'm waiting for your feedback. Okay. Good luck.